Hi everybody, this is Mr. Manideep Gupta, Assistant Professor, Department of Aeronautical Engineering from MLR Institute of Technology. In the lecture series of Aerospace Propulsion, today the topic which we are going to discuss is parameters describing motion of bodies. Parameters describing motion of bodies. Let us start the presentation. So, coming to the overview of presentation, the topics which we are going to discuss today are, one is impulse and force. So, while discussing the parameters which describe the motion of bodies, velocity, acceleration, these are basic parameters which we know, but along with that, impulse and force, these are very important parameters which also needs to describe the complete motion of a body. Okay, so today we are going to discuss this topic. What is impulse? What is impulse? It denotes the change of momentum. It denotes the change of momentum. Suppose if I take a body, of mass m, okay, and it is moving with some velocity v, then the momentum of this body is given as mass into velocity. Mass into velocity, that is, momentum is given as m into v. So, this mv is the moment. Okay, impulse explains about the change in moment. Okay, it explains the change in moment. It is the change of moment. So, what is change of moment? If I consider moment is mv, the change of moment is delta mv. So, delta mv is nothing but impulse, and the symbol of this impulse is capital I. Okay. So, here I am going to explain the impulse. So, if here I am considering, here I am showing one graph here. So, here you can observe the change of momentum, that is impulse is shown here. So, what is given in this here is, so this is impulse. Okay. So, impulse of a body at a particular time. This is a momentum, P is given as momentum. So, here if I take a body, initially the velocity is constant, the mass of the body is m, the velocity is constant here. So, here you can observe with respect to time the momentum is not changing, velocity is constant up to time t here. After a time t, we applied some force, external force on the body. So, that what happens is the velocity is changed from v1 to v2. The velocity is changed from v1 to v2. So, the moment mv also changed from p of t to p of t plus delta t. So, the duration about which we applied the force is t to t delta t, t plus delta t. We applied this force, external force on the body from time t to t plus delta t. So, because of this, the momentum is increased like this. Right? So, the change in moment. What is the impulse? The change in momentum. So, initial momentum is what? P of t. Final momentum is what? Momentum at t plus delta t time. Momentum at time t plus delta t. So, difference of this momentum at t plus delta t and momentum at time t, that is nothing but impulse. Momentum at t plus delta t minus momentum at time t seconds. So, this is nothing but impulse. Impulse is equal to, if I consider the velocities at the second after applying force is v2 and velocity before applying the force is v1, then impulse is equal to mv2 minus mv1. Here the mass of the body is constant. The mass of the body is not changing. Then the impulse is mv2 minus mv1, that is given here. But if you observe the change in momentum, how this change in momentum is momentum changed, the manner how the momentum is changed from time t to t plus delta t is different. It is not actually linear. So, the momentum can change like this. And also the momentum can increase like this. Here the momentum is increased like a curve like this. whatever the manner, okay, whether it is following the graph like the momentum changed like this, or momentum changed like this, or momentum changed like this, doesn't matter. Impulse just gives the change in momentum from one time to another time, that is t plus delta t to t. That's it. Then, but here the manner how the momentum change is, if you take this one, it is changing linearly, momentum is changing linearly. Here the momentum is changing like a sinusoidal wave, like a curve, convex curve, concave curve. So, but this impulse is not explaining the manner how this impulse is changing, this momentum is changing. So, we need another parameter to explain how this momentum is varying, how the momentum is varying. Okay, that is also important, right? So, that parameter is explained by force. That is nothing but rate of change of momentum. What is that? Is nothing but rate of change of momentum. So, next, that is nothing but called as force. So, the rate of change, what is force? Force is the rate of change of momentum. Force is the rate of change of momentum. That rate of change of momentum can be observed here. So, we discussed it, right? So, here the rate of change of momentum, if you see here, how the momentum is changed. Initially, momentum is 0, or there is no change in momentum. Slightly momentum is increasing. So, how do you calculate the rate of change of momentum? That is nothing but the delta y by dy by dx. So, if you take the slope at particular point, that slope will give you the rate. Okay, here the slope is less, and here you can increase. Here you can see the slope is very high, and again here the slope is again decreasing. That means the momentum is the momentum is increasing slowly from this point to this point. In this portion, the momentum is increasing slowly. Here the momentum is maximum, the change in momentum is maximum, and here the momentum, the rate of change of momentum is decreasing here. The slope is gradually decreasing here. Okay, so this is explained by the force. Okay, so an average force, suppose if you take average force delta F, then therefore it is defined as it is defined over the period of interaction delta T, that is taken as F is equal to delta P by delta T. The change in momentum, that is delta P divided by delta T, how much time it is taken. So, impulse is just P of T plus delta T minus P of T. This is impulse. So, force is impulse, change in impulse by delta T. That means impulse divided by delta T here. So, force is nothing but impulse, how much impulse is changed with respect to how much duration, that is given by force here. That is average force here. But this impulse, change in impulse can be uniform or it can be variable. So, here impulse is P of T plus delta T minus P of T, that is equal to, from this we can write impulse is equal to F into delta T. Next, F is equal to dP by dt is a rate of change of momentum, we have already gone through. And if you observe the how can this variation is observed. So, how I can explain this force variation. So, here in this second graph we can see the variation of this force acting on the body, that variation of momentum, how this momentum is increasing and decreasing, that is nothing but rate of change of momentum. So, here you can observe up to time t there is no external force applied. Okay, this is force, right? Here it is momentum increase like this. Here you can see the force in the second graph. So, force is, there is no external force, so there is it is 0. At time t, this is the force. So, the force applied on the body is continuously increasing up to some point A. Up to this point A, the force is continuously increasing. After that, we are decreasing the force applying on the body. So, that is decreasing. And finally, at time t plus delta t, the force applied on the body is 0. At time t, the force applied on the body is 0, and at time t plus delta t also, force applied on the body is 0. But what happened in between time t to t plus delta t? we gradually increased the force applied on the body up to some extent, and after point A again we decreased the force applying on the body. So because of that, the velocity of the body is changing. How the velocity of body is changing? So it is slowly increasing. After that, again slowly velocity of the body is, the change in velocity of body is finally constant. So here the velocity is, finally the momentum is constant after this point. So it is having constant momentum. That's why it is denoted with straight line. And here you can see the force applied on the body is 0. So whatever this is how the force applying on the body. So this is also important. Based on this, we can understand what is the final velocity attained by the body based on the force, how the force is applied. If the force is applied linearly, then the momentum may be different. The momentum achieved by the body may be different. If the force is applied linear, like a parabolic curve from t to delta t, the momentum applied by the body may be different like this. So based upon the rate of change of momentum, the final momentum of a body will differ during a time t plus delta t. So that is why impulse and force, these two parameters are very important to analyze the motion of a body, right? So let us discuss a small problem on this topic, momentum. Okay, what is the problem? So if you go to the average force is dp by dt, and if you go to the rate of change of momentum, the definition is d by dt of mv. Momentum is mv, rate of change of momentum is d by dt of mv. Suppose if you consider here m is mass, v is velocity. Here if I consider m is equal to constant, then this equation will become f is equal to d by dt of velocity into mass. Because mass is constant, then it can be written as mass into dv by dt is as acceleration, that is ma. Suppose if in this equation, if velocity is constant, in this equation, then what happens? This f is equal to, velocity will come out, then this equation will become dm by dt. So then what happens? V into dm by dt is nothing but mass changing with respect to time. So that is nothing but mass flow rate m dot. Dm by dt is m dot. So we can write this as m dot v. Suppose if velocity is constant, the force is written as m dot v. If mass is constant, then it can be written as mass into acceleration. So these are the two different cases. The different formulas we will get further to calculate the force in different cases. One is mass constant case, another is velocity constant case. Okay. So let's discuss one small problem here. Consider the problem is a momentum. Consider the momentum of a 100 kg. Okay, a momentum of 100 kg meter per second is imparted on a projectile over a duration of 0.05 second. Then what is the impulse? Okay, very simple. Momentum is already given 100 kg meter per second, and he is given the duration, that is time t, and he is asking the impulse. So impulse is equal to 100 kg meter per second. 100 kg meter per second is nothing but change in impulse. What is impulse? Just a change in momentum, delta mv. That's it. It is independent of time. This impulse is not dependent on the time duration, how much time it is taken by the body to change its momentum. It doesn't matter. It can take 5 seconds, it can take 10 seconds, whatever it may be, just a change in momentum of the body from one point to another point. That's it. That is impulse. So here the impulse applied is 100 kg meter per second. This is the change, the impulse, change of momentum of the body. Then next is also asking us to calculate the force acting on the projectile. So what is force? Impulse per time. So impulse is already got impulse, that is 100 Newton per second. So 100 divided by 0.05 will get 2000 newtons. So 2000 Newton force is applied on the body, so that the momentum, the impulse has the momentum is this. it has reached to 100 kg per second. So this is the problem. And coming to the summary, today we have discussed the topics impulse, average force, force, and a small problem on impulse and average force. Thank you.